The sun's photosphere burns at 5,500 degrees Celsius, hot enough to vaporize steel in less than a second. But that is only the surface. Beneath it lie layers so extreme that human language barely has the words to describe them, and above it stretches a crown of fire so vast it swallows the orbit of Mercury whole. Right now, 8 light minutes away, a ball of plasma is converting 4 million tons of mass into pure energy every single second. What happens if you cross into it, layer by layer, and never come back out? The corona is the first layer you would reach, the outermost atmosphere of the sun, and it is stranger than anything below it. It stretches millions of kilometers into space, visible from Earth only during a total eclipse, when the moon blocks the blinding disk and reveals this ghostly halo. Here is the unsettling part. The corona is hundreds of times hotter than the surface directly beneath it, reaching over 1 million degrees Celsius, even though it sits farther from the sun's core. No one has fully solved why the outer layer runs hotter than the inner one. Falling through the corona, you would be stripped down to your component atoms before you ever felt a shockwave, torn apart by radiation long before heat became the issue. But the corona is where the sun's true weapon is built. That weapon is the solar wind, a constant stream of charged particles, blasting outward at speeds up to 3 million kilometers per hour. It is not a wind in any breathable sense. It is a river of plasma flooding through the entire solar system, shaping the tails of comets, and battering every planet it passes, including Earth. Our magnetic field deflects most of it, which is the only reason life on the surface is possible at all. Strip that shield away, and the same particles that paint the aurora would instead scour the atmosphere into space over geological time. The solar wind is dangerous from a distance, but the next layer down would erase you on contact. That layer is the chromosphere, a thin reddish shell just above the visible surface, roughly 2,000 kilometers thick. It burns with a color astronomers only see during eclipses, a thin ring of pink fire framing the black disk of the moon. Temperatures here climb from around 4,000 degrees Celsius near the bottom to 20,000 degrees near the top, an inversion that still puzzles physicists studying stellar atmospheres. Falling through it, your body would not simply burn. It would be converted into plasma, its atoms stripped of their electrons, indistinguishable from the gas around it within a fraction of a second. If you have made it this far into the sun without turning back, drop a like and subscribe, because the next layer is where the sun stops looking like fire and starts looking like something with teeth. That is the photosphere, the visible surface, the layer most people mean when they picture the Sunday. It burns at roughly 5,500 degrees Celsius, and it is not solid. There is no ground here, no floor to stand on, only a boiling ocean of plasma stretching in every direction. Granules the size of Texas bubble and collapse across its surface, each one a churning cell of rising and falling gas that lasts only minutes before dissolving into the next. Sunspots the size of Jupiter appear here too, dark only by comparison, still thousands of degrees hot, marking regions where the sun's magnetic field twists and knots against itself. But the photosphere is a thin skin over something far more violent, and crossing it means leaving light behind entirely. Below the photosphere is the convective zone, and this is where things become strange. Sunlight cannot travel through this layer in a straight line, because the plasma here is so dense and turbulent that photons are absorbed and re-emitted over and over, bouncing randomly for what can take hundreds of thousands of years before finally escaping as visible light. A photon born at the sun's core right now will not reach your eyes for millennia. This layer moves like a pot of boiling water the size of a star, Hot plasma rising, cooling, sinking, and rising again in a cycle that never stops. Falling into the convective zone means falling into currents that would crush and disperse you before you sank a single kilometer further. And beneath that violent churn lies a layer defined not by turbulence, but by silence. That is the radiative zone, and it could not be more different from the chaos above it. Here, energy moves outward, not through bubbling motion, but through radiation alone, drifting molecule by molecule through plasma so dense it resists nearly everything trying to pass through. Temperatures reach around 7 million degrees Celsius, and pressure compresses matter into a density many times that of solid lead. No sound could travel here. No light could move freely. Just an unbroken, crushing stillness despite the extreme heat. If the convective zone is a storm, the radiative zone is the suffocating pressure beneath it, patient and immovable. But even 7 million degrees is nothing compared to what waits at the very center. That center is the core, and it is where the sun manufactures the energy that reaches Earth as sunlight. Temperatures here reach approximately 15 million degrees Celsius, and pressure is roughly 250 billion times what you feel standing at sea level on Earth. This is where hydrogen atoms are forced together through nuclear fusion, fusing into helium and releasing the energy that eventually, after that centuries-long journey outward, becomes the warmth on your skin. No structure, no solid matter of any kind could survive intact here, not for a fraction of a second. This is the absolute floor of the furnace. And yet even the core is not the final layer, because there is one more boundary, invisible and immaterial, that swallows everything before it ever gets this far. That final boundary is the sun's gravity well itself, the curve in space that every layer above sits inside. It is not made of plasma or heat. It is the reason none of this ever escapes, the reason 4 million tons of mass can vanish into energy every second, without the sun losing its grip on 8 planets, dozens of moons, and a swarm of smaller worlds. Fall toward the sun from far enough away, and gravity alone will accelerate you to hundreds of kilometers per second. Long before you reach the corona, meaning by the time you feel the first layer of heat, you are already moving faster than anything built on Earth has ever traveled. Every layer this video described, the wind, the chromosphere, the boiling photosphere, the silent radiative zone, the fusing core, exists only because gravity holds it all in place. A single invisible hand shaping a star that could swallow more than 1 million Earths. Somewhere in that structure is the answer to why a star, this violent, can also be this stable, burning steadily for billions of years instead of tearing itself apart. It is not calm. It is balance, an equilibrium between the outward pressure of fusion and the inward pull of gravity, holding a firestorm in perfect, silent tension. Understanding that balance is part of understanding every star like it's scattered across the galaxy, each one running the same furnace, each one holding the same invisible tug of war between explosion and collapse. If you want to keep exploring what the universe is hiding in plain sight, the next video on this channel goes even further outward, past the edge of the solar system, and into the objects that make stars like our sun look small. Subscribe before you go, because the next layer of this universe is waiting, and it is stranger than anything you just fell through.